In this video, I'm going to be revisiting those physics concepts, the position, velocity, acceleration, that we've looked at once before in this course when we only knew how to take a derivative. But now that we know how to take an integral, we're going to be able to do more stuff. Maybe we'll be able to be given the velocity and draw conclusions about the position, or be given information about the acceleration and, look at some things like distance and displacement. So, when we start, let's kind of write down what we're talking about when we say distance and displacement. And so when I say distance, I mean like the actual total distance traveled, as in how far you went. It's kind of like the odometer in the car, or when you look at your phone, or if you have one of those things that goes on your wrist that tells you, how many steps you took and how far you walked in a day. Those don't care whether you're going southwest or south or forwards or backwards or whatever. It's just counting how far you went, everything being forward. Whereas displacement is how far you are from where you started. Another way of saying how far I am from where I started is change in position. So I'm going to actually write down a little something about change in position. I'm going to talk about the x-coordinate at time 2, or just the position at time 2, minus the position at time 1. Well, I'm just going to point out that this is what we would get if we integrated velocity from time 1 to time 2, right? Because, we're going to find an antiderivative for velocity, that's position. I'm going to plug in T1 and T2. I'm going to subtract. So this is what I'm going to have. So if we're just integrating velocity, we're going to get displacement. We're going to get net change in position. But that should make sense, right? Because so far we've seen that when we integrate a rate of change, we're actually seeing the net change in the amount. All right, so it's, it's around the time of year where it's, the election season or whatever. And I was thinking the first time I did this lesson, a few years ago, it was kind of a big election, and I went during my conference period to go cast my ballot at, the local Randalls. But the important thing is I'm going to kind of look at this twice from a perspective of distance and displacement. The important thing was, I was sitting here in my squeaking chair, doing my thing, and class let out. It was my conference period. I got up, I got in the car, I drove to the Randalls, I cast my ballot, and then I came back, and I ended up back in my chair at my desk where I started. So in total, my displacement was 0. So let me just draw maybe a little graph of my velocity versus time. Okay, so I'm starting off with no velocity. Class has just ended. Okay, I get out on the road, probably reach some sort of like maximum speed. You got to slow back down so I don't, just blast through the wall of the Randalls. And okay, I'm there, I'm at the polling place, and let's just say for simplicity that, I kind of take the same route back, the same speed. Well, since my displacement was 0, I know that the area under the graph of V should be 0. But that actually makes sense based on my little narrative, like I go forward, I go backwards. Looks like my drawing was a little off, but, this seems plausible, that the integral of V of t dt from, let's say it took 30 minutes, from 0 to 30 was equal to 0. Okay, there was no displacement. I started off in my chair, I ended up in my chair, there was no change in position. Okay, but if you ask my car, it would say, well, actually, dude, you traveled 3 miles, because, I've got 3 more miles on my engine now than I did, 30 minutes ago. So let me draw a picture of the velocity versus time, or just, what's going on from the car's perspective. Okay, so, I get there, stick around for a while doing my voting thing, and picking back up with a little more of the same. Okay, so it's considering everything to be positive. Well, my question is, what kind of transform did I do on the first graph to get the second graph? If I took everything that had been negative and I made it positive. I took the absolute value of velocity. Okay, so really this is the graph of absolute value of velocity versus time. And it's not unreasonable to say that probably the integral from 0 to 30 of the absolute value of v of t dt is, I don't know what it was, but it's greater than 0, right? I know that if I traveled to the polling place, I had to have traveled some distance because I don't work at the polling place. All right, so let's go back and let's write down the formulas. Okay, remember displacement, I actually already wrote that it's the integral of v of t. Total distance is going to be the integral from t1 to t2 of the absolute value of v of t dt. Okay, now there's something else I'm going to point out to you before I move on to the actual. Okay, I'm going to kind of call back the fundamental theorem of calculus. Except I'm going to say if I'm integrating from a to b, f prime of x, I can do that by anti-differentiating, right? An antiderivative for f prime of x would be f of x, plugging in b, plugging in a, and subtracting, right? But if I added f of a to both sides of this equation, I could say that f of b is equal to f of a plus the integral from a to b of f prime of x. Okay, we'll be using this quite a bit today and honestly kind of the rest of the way through. Okay, and I really like this version of the fundamental theorem of calculus because it makes a lot of sense to me. That your ending value is given by your starting value plus the accumulation of some sort of rate of change, right? That's how you get change, is, especially for, if the rate of change is variable, is that, it accumulates over time. If it's changing a lot, and for a while, it'll change more in that time period than if it was just changing slowly. Okay, so, and we see that in terms of areas under curves, all right? Now, today, we're going to be interested in saying position at time B is going to be position at time A plus the integral from A to B of the derivative of x of t. Well, the derivative of x of t is velocity. Okay. So that's something that we're really going to need today. Okay, first I'm going to ask you, I've got this object moving on the x-axis. It's got velocity given by v of t is -1 plus 2 sine t, for t being between 0 and pi. And the question is, at the end of its motion, is the object to the left or to the right of its initial position? All right, this sounds like a displacement situation. To the left or to the right, that's, kind of like, what's the net change in position? Is it positive or is it negative? So I'm going to set up for that. I know I find displacement by integrating v of t. So I'm going to integrate from 0 to pi. V of t is -1 plus 2 sine of t. And this is an integral that you should do on your own, whether you're sitting here in class right now or whether you're watching at home on the internet. You need to practice your integrals. So what you should do, you should pause the video, work it yourself, and then, then press play, and the answer will just pop right up. All right, there you go. Okay, so I've evaluated the integral. I found an antiderivative. I plugged in pi. I plugged in 0. I subtracted. There was a lot of negative signs in there. But I ended up with negative pi plus 4. And since I know that pi is bigger than 3 but less than 4, I know that this displacement is a positive number. So since the displacement is positive and I'm moving along the x-axis, what should I conclude? Is it to the left? Is it to the right? What do you think? Yes, to the right. It's to the right of its initial position. Okay, now we've got a particle motion situation. A particle is moving along a line with velocity given by v equals t times sine of 3t plus 2 at time t. Oh, this is a calculator situation. Okay, this is the type of function v of t that we will be able to take an antiderivative for in the second semester once we get a product rule for antiderivatives, but we don't have the tools to do that yet. Okay, we need UDV, basically. We need integration by parts. We don't have that yet. So, in the absence of that, what we'll do is we'll use technology. Okay, the total distance traveled by the particle during the time interval 0 to 2. All right, so I need to bring in the calculator. All right, so I brought this in. Now, if you're sitting in my class, you've got this note sheet sitting in front of you. You can see that there's 3 different questions I'm about to ask about this velocity function. If you're going to need velocity, or if you're going to need any function on the calculator more than once, you're best off to type it into y equals so that we can just call on it from y variables. Now, the thing I do need to point out is that if you're going to use the calculator in this class at all, you got to be in radian mode. Okay, I know physicists, y'all are frequently in degree mode. You got to be in radians in here. Okay, otherwise you're going to have the wrong answer. Okay. What is the total distance traveled by the particle during the time interval 0 to 2? Well, we have a formula for that, right? We just learned that the total distance traveled is going to be the integral from 0 to 2 of the absolute value of v of t dt. And I'm realizing I did not type in v of t into y1. Okay, so let's do that now. T sine of 3t plus 2. All right, and that's all I need from that for now. Okay, so I'm going to quit. And the integral, we get to that in the math menu. It's number 9. Okay. And if you are operating with a TI-83, you'll have to, go look up the syntax on the internet. You could just type into, your favorite search engine, integration syntax for TI-83. Or if you have a different type of calculator and you don't know how to integrate, it's not a TI-84 plus CE like I'm working with right here. I'm going to go from 0 up to 2. And absolute value, that's inside math also, but it's over here with number. So you go over to the right, and it's the first thing, absolute value. Absolute value of v of t. Well, I plugged v of t into y1. So we get that from over here at variables. It's right next to clear. I knock over to y variables, function. We're in function mode. We'll do parametric and polar mode in the spring. And we're going to look at function y1, because that's v of t. Okay. With respect to t, and I'm going to press enter and let it think for a second. And that's where I get 1.311 total units of distance. Okay, valid point from the class that you can call on y1 by pressing alpha and F4, and I did not realize that. I think maybe I had known that at one point, but I'm just so used to going to variables, y variables, function mode, that it might be a hard habit for me to break. Okay, but that might be useful to you. Alpha menu, alpha F4, get your y1. All right. Next, it's asking you about what is the particle's average velocity over the time interval 0 to 2. Well, if we had the position function, we would take the average rate of change of position. They gave me velocity, so if I'm looking for the average velocity, I'm going to take the average value of velocity in the average value sense, like we learned, a couple times ago. So I'm going to say, well, this looks to me like a situation where I would want to, take the average value 1 over 2 minus 0 times the integral from 0 to 2 of v of t dt. Remember, we're going to find the average by adding them all up and then dividing. Right? So this shouldn't be too hard. 1 over 2 is a half. Or one thing I might do, I might use the fraction bar. Right? We can do that. You can call on an integral within the fraction bar. It's just going to look a little small. Okay. So there you go. Number 007. I'm using your technique. y1 with respect to x, divide by 2 minus 0. Just like we wrote it down. And then we get 0.053. Remember, in this class, always rounding to 3 decimals. If you wanted to write this as 0.052, because you're just reading off the first 3 digits you see, that's also acceptable. Okay, you can do that. Either way. All right, the last question I've got for you in this situation is, what's the average speed? Okay, so that's going to be a little different. You might remember what we said speed was in the past. Oh, Oh, okay. Actually, that is an interesting point. It's total distance over total time. That is true. We just said that in its most general form, speed is the absolute value of velocity. Okay. Yes. Okay. So speed equals absolute value of velocity. So average speed would be the average value of absolute value v. So that's, 1 over 2 minus 0 times the interval from 0 to 2 of the absolute value of v of t dt. But 884 sitting over there, that was a really interesting point that nobody else made in any of the other sections, was that you can find speed, average speed, by total distance divided by total time. And if you look, isn't this just like that same integral that we use to find total distance just divided by 2? I mean, it is. I could just kind of call on second entry. I need to go back another one. Yeah, there it is. And then maybe I'll just divide by 2. 0.656 or 0.655, whichever one you want it to be. All right. Now we've got a rabbit running back and forth on a straight track with velocity v of t equals t minus 3 cosine of 2t. Okay, I had to throw in a function where it's a composite function and the inside is a constant multiple of t or whatever. Just those mini chain rule examples. Got to do one every day. If his position is x equals 6, no, it looks like b, when t equals 0, what is his position at time t equals pi over 2? Well, that's where I was talking about at the beginning, what I've written in blue, that f of b equals f of a plus the integral from a to b of f prime of x dx. Okay, so I'm going to say that x at time pi over 2 is equal to x at time 0 plus the integral from 0 to pi over 2 of v of t dt. All right, well, x of 0 is 6. And then I'm going to need to find an antiderivative for these things. That's 1/2 t squared. Okay, so I would think -3, wait a second, yeah, -3 has, very good back there, sine of 2t. Just got to keep practicing our antiderivatives. Now, anytime I'm going to do something like that, I should probably stop and double check myself, because I know I'm very error prone. So I'm going to take the derivative, and I got -3/2 cosine of 2t multiplied by 2 for the chain rule, so yes, it works. Okay. All right, so I have 6 plus 1/2 pi over 2 squared. Well, pi over 2 squared is pi squared divided by 2 squared. Half of that would be pi squared divided by 8. Minus 3/2 sine of pi. I like that. That's 0. I know that one. And then, well, when I plug in 0, I'm going to have 0 squared and sine of 0. Both of those things are 0. And this is, I mean, not a pretty number, but it's 6 plus pi squared divided by 8 is the position at time t equals pi over 2. All right, now we're going to look at some free response questions from, somewhat recent AP exams. I've got 2 of them that I feel like are pretty typical, and I added one part onto the next one. But if you look through the free response packet for this unit, you'll see a lot of particle motion. Okay, very typical free response question for Calculus AB. In Cal BC, we're more likely to see a parametric equation, a 2-dimensional motion situation. But if we work really hard on our 1-dimensional motion right now, 2-dimensional motion will seem really easy when we hit it in January, February, whenever. Okay. V of t is given by 1 plus 2 sine of t squared over 2. I'll tell you, question number 2 on the free response, that's a calculator active question. So, and I can tell you just from looking at the other ones, we're going to need to use velocity more than once, so I'm going to go type it into y1. Okay, so I've told the calculator to make v of t y1. Right? Is the object speeding up or slowing down at t equals pi over 4? What am I going to need to check to determine whether something's speeding up or slowing down? Yes, I'm hearing all sorts of stuff. I'm hearing velocity, I'm hearing acceleration. Which one is it? That's a trick question. It's both. Yeah, you definitely do need to check acceleration. You're not wrong over there. You just need to also verify position. I mean, it's velocity. Because if the velocity is negative, but the acceleration is negative, that means the velocity is getting more negative, which would mean its absolute value is increasing. Okay, so I'll let you think about that for a second. So I need to check V of 4 and A of 4. All right, so let's do that for a second over here. I'm going to say, well, V of 4 is, well, I need to just let the calculator do that. Could we definitely plug in 4 ourselves and find 1 plus 2 sine of, I think, 8? Sure. Or we could call on y1 as if it was like f of x, use some parentheses, plug in 4, and the calculator knows what you mean. So that's 2.979. And I think that's pretty nice. Okay, I'm going to just do that. Okay. If I want to find the value of the acceleration at time t equals 4, what am I going to do? How do I find acceleration if I have velocity? Okay, so you all know that acceleration is the derivative of velocity, but I'm afraid that some of us might be, prone to just trying to calculate this using the calculator and then writing down the number there. You have to be explicit with the reader, with the grader, about what are you putting into the calculator? How are you getting A of 4? Give it to him in a calculus sense. A of 4 is the derivative of V at t equals 4. And now we're going to do this over here by numerically calculating the derivative. We're going to call on math. It's number 8 in deriv. We're going to take the derivative with respect to t of y1 at the point where t is equal to 4. Then we let it think for a while, and we get equal to negative 1.164. Okay, and since V of 4 and A of 4 have opposite sign, what am I going to conclude? Yes, definitely, slowing down. Right? So probably on this one, if you just found A of 4, found that it was negative, and said slowing down, you would have gotten no credit. Okay, you probably had probably in the scoring guidelines you would see something about considers the velocity at t equals 4. All right. Next, they're asking me to find the time or times between t equals 0 and t equals 3 when the object changes direction. Okay, so what should I be looking for? Like, what do I need to do? I'm going to have to do something with the calculator. Yeah, we're going to check velocity. What about velocity? Yes, when the sign changes, exactly. Okay, we're interested, when it equals 0, that's what it's going to be. But we really are interested in the sign change of velocity. And the fastest way for us to do that is to just produce a graph. But the thing is, the calculator, it defaults to going from negative 10 to 10 in the independent variable. I'm going to go over here and tell it to kind of just focus on 0 to 3, because that's what they told me. And now, oh wow, that happened quickly. So there it is, right there. I found one crossing point. So I'm going to calculate a 0. It's between, I don't know what that is, but a right bound would certainly be 3. Give it a guess. And that is looking like 2.707. But are we going to, be sitting there on the free response section of the AP exam and just write t equals 2.707? Of course not. Okay, we're going to have to justify our answer. So I'm going to say exactly what 582 said to me. I'm going to say it changed direction because V of t changed signs. Something to that effect. Part C asks you to find the position of the object at time t equals 0. Well, okay, that's another one of those, okay, x of 0 is going to be x of 4. But wait a second, it's kind of backwards. Okay? My advice on this situation is to just live with the formula we know. We know the fundamental theorem of calculus. We know f of b equals f of a plus the integral from a to b of f prime of x dx. So I'm going to say that x of 0 is going to be equal to x of 4 plus the integral from 4 to 0 of v of t dt. Right? Okay. Even though it's going backwards in time, I don't have to worry about it because the bounds being backwards will kind of take care of that for me. So I know that x equals 2 when v equals 4. So I'm going to do 2 plus the integral from 4 to 0 of v of t. Okay, well, v of t is y1 with respect to t. And I get negative 3.815. All right, and the last question they're going to ask in this free response question is, find me the total distance. Okay, this is the type of thing, we've done this enough already. I've done it on the calculator, I showed you how to do it. If you're watching at home, you need to do this yourself. So, you do it now. You pause the video. And when you press play, in a couple of seconds, it'll just pop up with the answer, and you can see if you've done it right. All right, there you go. All right, now we're going to look at 2012 AB free response number 6. This is a no calculator question. And this one's kind of interesting. It's got some elements I really like. When is the particle moving to the left? Well, moving to the left, that's when v is, what? V is negative, yes. So what I'm going to do, I'm going to need to sketch the graph of v. This is honestly one of the only times I've seen on at least recent AP calculus stuff where you would need to be able to sketch the graph of a trig function. I suppose you could find the zeros of it and do a sign chart if you wanted, but I'm going to just sketch a graph because cosine's pretty easy to sketch the graph of. And if you came to me from Mr. Schuler's class, you're in his pre-calculus, I know you're an expert on sketching trig graphs. And I know that if I let t run from 0 to 12, that's like letting cosine go from cosine of 0 to cosine of 2 pi. So I know it'll just kind of like finish off one of its usual cycles. All right, there we go. And I want to know when the particle's moving to the left. So v of t is going to be less than 0 when t is between, I don't know, these two numbers. So we got to figure out what those numbers are. But those are just the zeros of v. So really, okay, when is cosine equal to 0? I'm going to kind of go over here, and I'm going to think about that for a second. Cosine is 0, pi over 2, and 3 pi over 2. So that would be 3 pi over 6 and 9 pi over 6. But that actually kind of makes sense if, because we know about the symmetry of these graphs, 3, 6, 9, 12. Kind of makes sense to me. Okay? So it's moving to the left because of v being negative, and that happens when t is between 3 and 9. Next, write, but don't evaluate, an integral to represent the total distance traveled by the particle from t equals 0 to t equals 6. We should all be so lucky to get a question this easy on our AP exam, This is just write the integral. They probably gave you like 5 inches of space to do it, too, and trick people into thinking it was much harder than it was. Okay, there's going to be an integral. It's going to be from 0 to 6. Total distance is where I integrate the absolute value of velocity. And you could write in there cosine of pi over 6t if you wanted. That would be fine. But they already defined v of t to be that, so if you just call on v of t like that, you are good to go. Okay, so if they ask me to find the position of the particle at time t equals 4, well, it's going to be x of 4 equals x of 0 plus the integral from 0 to 4 of v of t. Okay, again, This is one that we're going to take by hand. So I think you should try this on your own. Check your answer against mine. All right, there you go. The position of the particle is -2 plus 6 root 3 divided by 2 pi. Let's see. This is, all right, I'll admit that part D I actually made up because it's, it's a really good question, but I couldn't really find one that asked it the way I wanted to that also had, by hand trig. Okay. I need to figure out whether this is positive or negative. So I am going to bring in the calculator. Okay, and it turns out that's -0.346. Okay, that's great. So I'll just say that that is less than 0. Now, what I've been working toward, and honestly can't believe that I have never asked this question. This is my 5th time around doing Cal BC, and I've never thought to ask, is the particle moving toward the origin or away from the origin? Now that I noticed it, I've seen it a couple of times in the free response. I really like this question because it's just like the speeding up or slowing down. If you think about it, if I'm determining whether it's moving toward the origin, well, that means that the absolute value of the position is decreasing, right? Which is kind of like the speed decreasing, right? And so we're going to do some analysis. So what we need is the position at t equals 4, which we just found to be negative. And we also need the velocity at t equals 4. So I'm going to go over here and I'm going to consider velocity of 4. Velocity at 4 is equal to cosine of 4 pi over 6. And we know that 2 pi over 3 is right there. And that's where x is negative. Okay, so velocity is negative. So if I'm over here and here is 0, and my position is negative and the velocity is also negative, meaning I'm moving to the left, well, the distance is increasing. So it's moving away from the origin. Due to the fact that v and x are both negative. So that's just something I thought I would point out at the end of the video. Might help you on a quiz or a test or something coming up pretty soon. So